In modern aviation, where technological prowess meets the demands of combat, one machine stands out as both awe-inspiring and formidable: the helicopter. Among these aerial marvels, a breed has earned the moniker of the most dangerous helicopter in modernity. Renowned for its stealth capabilities, unparalleled maneuverability, and cutting-edge weaponry, this helicopter represents the pinnacle of airborne lethality. Its design seamlessly integrates advanced technologies, allowing it to operate undetected, strike with precision, and dominate the skies with unprecedented agility. How does it outclass its counterparts in the ever-evolving landscape of aerial warfare? What secrets lie within its sleek design? Join us as we delve into the most dangerous helicopters in modernity. AH-1Z Viper, United States. The Bell. AH-1Z Viper, an evolved version of the Bell AH-1 Super Cobra attack helicopter, incorporates numerous enhancements compared to its predecessor. These improvements encompass new rotor technology, upgraded military avionics, advanced weapon systems, and integrated electro-optical sensors. The alterations result in heightened survivability, extended target detection ranges, and the capability to engage targets with precision weapons. The airframe underwent an extensive redesign for enhanced crashworthiness, incorporating features such as energy-absorbing landing gear, fuel vapor inerting systems, self-sealing fuel tanks, crashworthy seating with energy attenuation, and a mass retention design approach for major components. Active protection systems include countermeasure dispensers, radar warning, incoming on-way missile warning, on-fuselage laser spot warning systems, and the hover infrared suppression system to safeguard the engine exhausts. The AH-1Z features a bearingless and hingeless rotor system, significantly reducing parts compared to four-bladed articulated systems. The rotor blades, composite of composites for increased ballistic survivability, have a semi-automatic folding system facilitating more efficient storage aboard ships. Maintenance efficiency is maximized with fewer tasks. Interactive electronic technical manuals, reduced spare storage, improved accessibility, and fault detection sensors for condition-based maintenance compared to the Super Cobra. Equipped with redesigned stub wings longer than its predecessor, the AH-1Z accommodates additional stations for missiles like the AIM-9 Sidewinder, 2.75-inch Hydra 70 rocket pods, or AGM-114 Hellfire quad missile launchers. The cockpit design allows both crew members to have virtually identical controls, enabling operation from the front or rear positions. The hands-on collective and stick-side-stick architecture allows the pilot to perform numerous functions without moving their hands from the flight controls. The AH-1Z's cockpit features multi-functional liquid crystal displays, an integrated avionics system by Northrop Grumman, and a communication suite combining radio, UHF, VHF, ComSec, and modem functions. Thales' Top Owl helmet-mounted sight and display system equips crew members with a 24-hour day or night capability and binocular display with a 40-degree field of view. The Lockheed Martin Target Sight System, incorporating a third-generation FLIR sensor, enables target sighting and identification in diverse conditions, offering passive and untrackable operation. Mi-24 Hind, Russia. The fundamental structure of the aircraft originated from the Mi-8, also known as HIP in NATO reporting, featuring two turboshaft engines positioned on top that drive a mid-mounted 5-blade main rotor measuring 17.3 meters, along with a 3-blade tail rotor. The unique double air intake is a result of this engine configuration. Early versions sport an angular cockpit, while the Model D and subsequent models showcase a distinctive tandem cockpit with a double bubble canopy. Components from the Mi-14 Haze were also incorporated into the airframe. The Mi-24 boasts mid-mounted stub wings for weapon hardpoints, each offering 3 stations for equipment and providing lift. The mission determines the specific loadout. Mi-24s can be assigned roles such as close air support, anti-tank operations, or aerial combat. The rotor blades of the Mi-24, made from titanium, exhibit resistance to 12.7mm rounds. The cockpit is equipped with ballistic-resistant windscreens to enhance crew protection, and a titanium-armored tub surrounds the cockpit and crew compartment. In nuclear, biological, and chemical conditions, the cockpit and crew compartment are overpressurized for crew safety. Regarding flight characteristics, considerable effort was invested in making the Mi-24 fast. The airframe was streamlined, and retractable tricycle undercarriage landing gear was installed to reduce drag. The wings contribute significantly to a quarter of the total lift at high speeds. The main rotor is tilted 2.5 degrees to the right from the fuselage to counteract the translating tendency at a hover. The landing gear is tilted to the left to maintain rotor levelness when the aircraft is on the ground, causing the rest of the airframe to tilt to the left. The asymmetrical tail generates a side force at speed, unloading the tail rotor. A modified version of the Mi-24B, named A-10, set several speed and time-to-climb world records. The A-10, designed for minimal weight, had its stub wings removed. It held the absolute speed record for helicopters at 368.4 kilometers per hour over a 15 to 25 kilometers course until 1986. Compared to Western helicopters, the Mi-24, serving as an armored gunship and troop transport, lacks a direct NATO counterpart. Unlike UH-1 Huey helicopters used by the U.S. in the Vietnam War, which could serve either as troop carriers or gunships, but not both simultaneously, the Mi-24 was designed for dual roles. The American Sikorsky S-67 Blackhawk's closest Western equivalent shared similar design principles but was not adopted for service. Other Western counterparts include the Romanian Army's IR-330 and the MH-60 Direct Action Penetrator, a specialist armored variant of the Sikorsky UH-60 Black Hawk. AH-64 Apache, L, UK. The AH-64 Apache features a main rotor with 4 blades and a tail rotor with 4 blades. The crew sits one behind the other with the pilot positioned behind and above the co-pilot gunner. Both crew members can independently fly the aircraft and engage in weapon methods. The AH-64 has 2 General Electric T700 turboshaft engines with high-mounted exhausts on either side of the fuselage. Different engine models have been used, and those in British service utilize engines from Rolls-Royce. In 2004, General Electric Aviation began producing more powerful T700 GE701D engines rated at 2,000 horsepower for AH-64Ds. The crew compartment and rotor blades are designed to withstand hits from 23mm rounds. The airframe includes about 2,500 pounds of protection and has a self-sealing fuel system to guard against ballistic projectiles. A transparent blast shield is incorporated between the pilot and gunner seats for survival in the event of a direct hit, though the canopy and windows are not rated against ballistic threats. Meeting the crashworthiness requirements of MIL STD 1290 was a design priority. This standard outlines minimum crash impact energy attenuation requirements to minimize crew injuries and fatalities. Achieving this involved increasing structural strength and incorporating crash-worthy landing gear, seats, and fuel systems. Under standard conditions, about 15 degrees Celsius, the AH-64 has a vertical rate of climb of 1,175 feet per minute and a service ceiling of 21,000 feet. On a hot day, about 21 degrees Celsius, the vertical rate of climb decreases to 1,595 feet per minute, and the service ceiling drops to 19,400 feet due to less dense air. One notable feature is the integrated helmet and display sighting system, a helmet-mounted display allowing the pilot or gunner to control the 30mm automatic M230 chain gun with head movements. The AH-64 has various sensors and avionics for day and night operations in adverse weather conditions. Longbow-equipped Apaches can locate up to 256 targets simultaneously within 50 kilometers. Additional improvements include the Ground Fire Acquisition System, GFAS, for detecting ground-based weapons fire sources, and targeting and ongoing developments in targeting and surveillance sensors for higher resolution color imagery. The AH-64's armament includes the 30mm M230E1 chain gun, AGM-114 Hellfire anti-tank missiles, Hydra 70 unguided rockets, and other optional external stores. The AGM-114N Hellfire missile with a thermobaric warhead is designated AGM-114N. The AH-64E version can control unmanned aerial vehicles for scouting missions and can be fitted with directed energy weapons or other advanced munitions. The helicopter has undergone testing of various anti-armor missiles and is continuously adapted with new capabilities, showcasing its versatility in different roles within the close combat attack context. Eurocopter Tiger, France and Germany. The Tiger helicopter is proficient in various combat missions, such as armed reconnaissance, surveillance, anti-tank operations, close air support, and escorting and safeguarding friendly assets. It can operate day or night in various weather conditions and has been designed for operations following nuclear, biological, or chemical warfare. The Tiger is adaptable to maritime environments and capable of operating from ship decks, including frigates, even in extreme weather conditions. Notably agile, the Tiger can execute full loops and negative G maneuvers, partly attributed to its innovative 13-meter four-bladed, hingeless main rotor. A pair of FADEC-controlled MTU turbomecha, Rolls-Royce MTR390 turboshaft engines power it. Featuring a tandem-seat glass cockpit, the Tiger is operated by a two-man crew, with the pilot in the forward position and the gunner seated behind. Both crew members can manage weapon systems and primary flight controls with the flexibility to switch roles as needed. The Tiger's pilot oversees self-defense systems, communications, and certain secondary weapons functions. Noteworthy for its ease of handling, the Tiger demands substantial retraining for new crew members due to increased workload management and enhanced capabilities compared to older platforms. Survivability is enhanced through stealth measures, minimizing visual, radar, infrared, and acoustic signatures. The fuselage is armored, designed to withstand small arms fire and 23mm cannon rounds. Composite materials, including 80% carbon fiber reinforced polymer, contribute to reduced radar cross-section, infrared, and acoustic signatures. The Tiger is the first all-composite helicopter developed in Europe. Crashworthiness is a key design element, with redundant systems and components to minimize the impact of damage. The helicopter is equipped with protection against lightning strikes and electromagnetic pulses. The avionics suite includes Eurogrid battlefield management and map display systems, integrated communications, a digital automatic flight control system, and redundant data buses. The Tiger's navigational suite incorporates GPS, dual redundant inertial referencing, Doppler radar, air data units, radio altimeter, and airspeed sensors. The Osiris sight sensor, mounted above the rotor head, integrates optical TV and thermal cameras, a laser rangefinder, tracker, designator, and gyroscopes for stabilization, serving as the primary sensor for target observation and acquisition. Armament options for the Tiger include rockets, cannons, air-to-air, and air-to-surface missiles, controlled by a dedicated weapons control computer. The nose-mounted 30mm Nexter turret, external gun pods, anti-tank missiles, and rocket launches on the stub wings contribute to its versatile firepower. The Tiger's munitions capability encompasses a range of scenarios, leveraging its adaptability in combat situations. Mi-28 Havoc, Russia. The Mi-28, a modern attack helicopter, is an air-to-air and air-to-ground companion to the Mi-24 Hind and K-50 Hokum. Its design features a 5-blade main rotor positioned above the midsection and short, wide, tapered wings at the rear for weapons. 2 turboshaft engines with downturned exhausts are mounted atop the fuselage. The slender fuselage, tapering to the tail boom and nose, includes tandem cockpits, a belly-mounted cannon, and non-retractable tricycle landing gear. The crew can survive a vertical fall of up to 12 meters per second thanks to energy-absorbing landing gear and seats. The fully armored cabin, including the windshield, withstands 7.62 and 12.7 millimeters of armor-piercing bullets and 20 millimeters of shell fragments. Following a conventional pod and boom configuration, the Mi-28 incorporates a tail rotor with elastomeric bearings for the main rotor head and composite main rotor blades. The Mi-28N Night Attack variant features all-plastic rotor blades capable of withstanding 30mm shells. Equipped with heavily armored cockpits, the Mi-28N has a windshield resistant to 12.7 to 14.5 millimeters caliber bullets, in-nose electronics, and a narrow X-tail rotor. It is powered by 2 2200 horsepower Isotov TV3 117VM turboshaft engines. While not designed for transport, it includes a small passenger compartment for rescuing downed helicopter crews. The Mi-28N's features include a helmet-mounted display for the pilot, an integrated surveillance and fire control system, and an electronic combat system. The Night Attack variant incorporates an integrated electronic combat system, a new main gearbox, high-efficiency rotor blades, and an engine fuel injection control. The armament of the Mi-28 includes a chin-mounted NPPU-28 turret with a 30mm automatic Shipunov 2A42 autocannon. It can fire rounds from high-explosive incendiary to armor-piercing discarding sabot. The standard missile armament is the 9M120 Ataka V missile, with variants for different tasks. Unguided rockets like the S-13 and S-8, upgraded to laser-guided missiles with the Ugroza system, can be carried on pylons under the stub wings. Additionally, the Mi-28 can carry air-to-air missiles, air-to-surface missiles, and aerial bombs weighing up to 500 kilograms. Z-10, China. Come off, under a classified contract, collaborated with China on developing the Z-10 helicopter. Initial specifications like weight, speed, and payload capacity were established jointly, after which Kamov created an early design that underwent significant modifications by the Chinese team during prototype construction, flight testing, and subsequent development. For the Z-10's flight instrumentation, 2 configurations exist, one derived from a foreign system, possibly French, and another indigenously developed. Both configurations share a holographic heads-up display, with differences in the number of color LCD multifunction displays. The choice between these configurations, determined by modular design, is believed to cater to potential export customers' preferences, with the 2-piece MFD version reportedly selected for service. Mission-related avionics include an electro-optical fire control system combining French and Israeli experiences in hardware, but entirely China-developed software. The Z-10 features a helmet-mounted sight and night vision, providing navigational information on multifunction displays and compatibility with night vision goggles. The Z-10's cockpit, configured in a stepped tandem layout, accommodates a gunner in the rear and a pilot in the front, differing from conventional attack helicopters. The canopy is treated to prevent glare, and bulletproof glass offers protection against shrapnel and rounds up to .50 caliber. The Z-10 is powered by the domestically produced WZ-9 turboshaft engine, offering a modular design concept for various weaponry, including machine guns, cannons, rockets, and missiles. The helicopter can carry up to 16 missiles on its 4 hardpoints. The armament includes a 23mm automatic chain gun and the ability to deploy air-to-surface and air-to-air missiles, including the TY-90 for aerial combat. Unguided rockets of various calibers can also be mounted under the stub wings. The modular design allows the Z-10 to be armed with weaponry of both Soviet and Western origin, facilitated by the Chinese GJ-V289A standard databus architecture. Ka-50 Hokum, Russia. The K-50 and its two-seat variant, the K-52, are advanced combat helicopters designed for day and night operations, boasting high survivability and firepower capabilities for engaging air targets and heavily armored tanks equipped with air defense weaponry. The helicopters were conceived to be compact, swift, and agile, enhancing their survivability and lethality. Regarding maneuvering, the K-50 achieves a hovering ceiling of 4,000 meters and a vertical climb rate of 10 meters per second at an altitude of 2,500 meters. Its coaxial rotor system, featuring polymer blades, contributes to low inertia along both vertical and lateral axes, providing enhanced agility with a maximum vertical load of 3.5 grams. The absence of a tail rotor enables flat turns at all speeds. Navigation systems on the Ka-50 include an inertial navigation system, autopilot, and a head-up display. The helicopter is equipped with sensors such as forward-looking infrared and terrain-following radar. Additionally, it incorporates an electronic radio and sighting piloting navigating system that facilitates day and night flights in varying weather conditions. This avionics system allows for precise target designation with a digitally coded communication system, enabling information exchange between helicopters and ground command posts. The K-50 ensures protection and survivability through a radar warning receiver, electronic warfare system, and chaff and flare dispensers. The cockpit is extensively armored to withstand projectiles, and the rotor blades are designed to endure hits from ground-based automatic weapons. The helicopter incorporates a global rescue ejection system, a pioneering feature allowing the pilot to escape at any altitude and speed. The K-37-800 rocket-assisted ejection system facilitates safe ejection by detaching the rotor blades before ejection. Armament on the K-50 includes a Shipunov 2A-42 autocannon with selective fire, mounted for accuracy near the center of gravity. The cannon has a cyclic rate of fire between 200 and 800 rounds per minute and carries various types of ammunition selectable by the pilot. The fire control system facilitates real-time sharing of target information, enabling multiple helicopters to engage a target spotted by another aircraft or ground-based scouts. External hardpoints under the stub wings and wingtips allow the K-50 to carry a variety of weaponry, including Vickers laser-guided anti-tank missiles with a range of approximately 8 kilometers. The helicopter can also deploy rocket pods, such as the S-13 and S-8 rockets, with potential upgrades to laser guidance using the proposed Ugroza system. AH-2 Rooivalk, South Africa. Due to the South African Air Force's extensive helicopter experience in the challenging African environment, the Rooivalk has been specifically crafted to operate independently for extended periods without requiring sophisticated support. Sustaining the Rooivalk in flight merely necessitates a medium transport helicopter equipped with a basic supply of spare parts and a team of 4 ground crew members. The Rooivalk is equipped with various weapons tailored to its mission profile. Typically, it features a 20mm cannon mounted on the nose and can carry air-to-air missiles, anti-armor missiles, and unguided rockets. The helicopter incorporates a fire control system for target acquisition and tracking and an advanced navigation system utilizing Doppler radar and GPS. Additionally, the Rooivalk is equipped with an electronic countermeasures suite, complemented by chaff and flare dispensers. The helicopter features a gyro-stabilized sensor turret housing with auto-tracking utilizing the Thales Top Owl helmet-mounted display, a system developed by Société de Fabrication d'Instruments de Mesure in 1999 to 2000. Key characteristics include a tandem cockpit, a starboard tail rotor with a port tailplane, a fixed-wheeled undercarriage, and wire cutters positioned above and below the cockpit and on the undercarriage. Notably, the Ruivalk can perform a loop, allowing it to momentarily fly upside down. In the dynamic realm of modern aviation, these helicopters transcend the ordinary, embodying the epitome of airborne prowess. From the stealthy and agile Mi-24 Hind to the technologically advanced AH-64 Apache, each machine represents a fusion of innovation and lethality. The Eurocopter Tiger showcases adaptability, while the Bell AH-1Z Viper's evolution emphasizes survivability and precision. The Mi-28 Havoc and Z-10 exhibit Russia and China's commitment to cutting-edge warfare, while the Ka-50 Hokum stands as a testament to agility and advanced design. Lastly, the AH-2 Ruivalk exemplifies South Africa's ingenuity in crafting a helicopter tailored for the challenges of the African landscape. Thank you for watching. While you are still here, click the link on your screen to check out more videos. See you there.